Okay, so here we are at the bottom of page 5. We're in section 4.2, bottom of page 5 for the notes, so page 5b. And at the top of the page, the previous video, we did the beginning part of this problem, and part A was to find the x-intercept and interpret what that meant. So now I want you to try finding the y-intercept and describing what this means in terms of the car's values. So you have the notes in front of you. Pull that equation down and write it out, or use some extra space down here. See if you can figure out what part B is, and then we'll move on to C and D as well. But pause for now. When you come back, we'll reveal the answer for part B. Okay, so what you should get for the y-intercept is that it's the point 0.24,000, and what that means is that at years equal to 0, that's our x value, okay, it's worth, the value is $24,000, which means that when you buy it, it's not old at all, it's just fresh off the lot. When you buy it new, it's worth $24,000. You haven't had it for any time at all. That's what, when x is 0, that means no time at all, and the value is at its maximum, 24,000. Okay, so in part C, use the intercepts now. So you've got an x-intercept from part A, which we never wrote that as a point, so let me see if you can see this, if I'm still, oh yeah, you can still see this. So the x-intercept, the actual point, is the point, y is 0, x is 8. Yes, so it's the point 80 is your x-intercept. And your y-intercept we just found in part B, 24,000. So part C, you get to graph that, and because x and y must be non-negative, y, limit your graph to quadrant 1 and its boundaries. So hit the pause button, see what you can do with that. I'm asking you to push yourself a little bit. We've done a limit your graph and y already, so hopefully you can practice applying that, what we did, what you saw us do before. Now you do it yourself and answer the question, why would we want to limit it, and go ahead and limit it. And then we've been practicing using intercepts to graph. Now these numbers are kind of big, so you might want to scale it in a way. Okay, and then hit the pause button, do that, come back, we'll see how you did. Okay, so I'm going to give myself a little bit of space here. Your graph should look something like this. You're going to be limiting it to quadrant 1, so you're only going to see positive x and y's. And the reason why is because you're talking about, you can't have negative values here. You can't have negative values for x because x represents time, years. And you can't have negative values for, nor can you have them for y, because y represents the value in dollars, and you can't have negative dollars. Okay, so a car has to be worth something or 0. It's not, you can't run a car down to the point where you turn it in and you have to give them money to take it away, although possibly in real life you might have to pay people to take your car away. So, but the idea of its value in terms of would you be able to resell it, that's what they're talking about here. So these have to stay positive. So you take your intercepts and you've got 0, 24,000. So let's go 8, 16, 24 here. And it's at the point 0, 24. And then let's go 8, 16, 24. Just to kind of get a good scale here. And so we had a y-intercept of 0, 24,000, and we have an x-intercept of 8, 0. So then our graph is limiting it to quadrant 1. It just goes from endpoint to endpoint, intercept to intercept. We will not extend this one because there are not an infinite number of possibilities here. The car's value starts at 24,000. It depreciates down this line down to 0 after 8 years. Okay. So now it says in part D to use your graph to estimate the car's value after 5 years. Now hopefully you were able to draw a graph clean enough that you could maybe divide this into little chunks. I did not do that great of a job here, so I'd have to kind of estimate a little bit past halfway. But anyway, hit the pause button, see if you can estimate what the value would be after 5 years, come back, and we'll get the answer. Okay, so here we are after 5 years, so x is equal to 5, y is approximately what? So we're going to use the graph. We could use the equation to come up with exactly what it would be, but we're instead practicing using the graph to estimate it, what it would be. So we'd go here a little bit past the halfway point would be x equals 5, go up to connect to the graph, and we're at a point just past 8. Looks like it's approximately the 0.59,000 here. So it's approximately $9,000 when x is equal to 5. Which brings us to our final point for section 4.2. Why would we even care about graphing lines? Because if we have the equation, we could have just plugged this into the equation and got the exact answer. Well, here's one reason why we want to graph lines. There's plenty, but here's one to think about. If we have some real data and we plot it on a graph, chances are it may not make a perfectly straight line, okay? But it may be sort of a pattern to it, okay? There may be sort of a pattern. If we see a pattern or a general kind of movement to it, then we can use our graphing skills to kind of give what's called a line of best fit. We can then use our algebra skills to come up with that equation, and then we could use either the equation or the graph to predict what other values are, values that we didn't find in our real set of data, okay? We would use either the graph or the equation to predict other values not in our original data set. So that's one reason why we want to be able to graph lines, to see if we can, and to go back and forth between the graph and the equation, is to be able to see if we've got something that represents the data in general. It's not perfect, but it's fairly close. And then we could use that to predict measurements that we didn't take in our original data set. Okay, but there's lots of other reasons too, and as we move towards Math 65 and kind of wrap up, I'll talk about some different things that we can do with lines and our ability to graph lines, and not just in the math world. The patterns and noticing things, that's a good skill in life too. So, and to be able to progress along a linear projection. So, all right, but that's more later. So always we finish with some review problems to help keep you from rusting over. We want to keep you fresh, keep practicing, especially for those of you that struggled a little bit in chapter 3 with the story problems. If there's not a story problem listed in the review, you take the time to go back and grab a story problem and practice it. It will help get you ready for the secondaries. Even just practicing one word problem a day will make a huge difference come secondary time. And I know a lot of you are aiming to improve your scores, to get a higher final exam score and to just improve your exam 2 score. And always some preview exercises which will get you ready, kind of primed for 4.3, and we will see you then.